Hello everyone, my name is Hamane Edwards, and today's video clip will be on slope. I'm going to introduce slope, its properties, and applications. Now, without using any numbers or doing any calculations, you can determine if one line has a greater slope than another. Now observe these two different lines, A and B. You see how line A is much steeper or has a greater incline than B? Well, slope is defined as the direction and steepness of a line. Since line A is steeper or has a greater incline than line B, we can say the slope for line A is greater than the slope for line B. Now observe these two lines, D and E. If we wanted to determine which slope is greater, it's not as easy as before, because the two lines aren't in the same direction. The slope of a line can be negative or positive depending on the equation of the line. So as mentioned before, to find the slope of a line, you need 2 points that are on the line. Now, let's say we have point 1, which is equal to x1, y1, and point 2, which is equal to x2, y2. And I put the 2 points in different colors for a reason you will notice next. Now to find the slope of a line, you take the change in y values divided by the change in the x values, or difference in y values divided by the difference in the x values. So this is equal to y2 minus y1. Sorry, I'll put that in red. Divided by x2 minus x1. Now, a common mistake when taking the slope that students seem to have is, instead of taking the difference of y values in the numerator and the x values in the denominator, they would switch them. So they will be taking the difference of the x values in the numerator divided by the difference of the y values in the denominator. But this is not right. It does not follow the equation. Make sure you do not do it that way. So, for example, let's find the slope of a line with points 1, 2, and the second point equaling 5, 7. Now, following the equation, we use 7 as y2 and 5 as x1, 2 as y2, and 1 as y1. Sorry for the crowding of numbers. But fitting into the equation, we have 7 minus 2 divided by 5 minus 1, which equals 5 over 4, which is our slope of the line. So an easier way to remember the y2 minus y1 divided by the x2 minus x1, an easier way to remember the slope, the equation of a slope of a line, I like to think of rise over run. Now, taking the same points, we used an example earlier, 1, 2, and 5, 7. We're going to use this technique of rise over run. Basically, it means, given a line, you start at 1 point. So I'm going to start at 1, 2, and first you rise. So we're going to rise up to the second point, which is 1, 2, 3, 4, 5 units up, and they're going to run, meaning the change in x. 1, 2, 3, 4. So the rise over run equals 5 over 4, which is the same slope we got doing the mathematics computations. So in the example we just did, the slope of the line ended up to be positive. Now I'm going to go over the slope of a line that is in fact negative. So let's consider the line here. And let's call that line A. Now, so to find the slope, we do the same steps. We pick 2 points along the line. So I'm going to pick that point. So point 1 equals, we count over 3 units, up 4 units. So 3, 4. And point 2, I'll take this point at the very end, which is over 1 unit, up 6 units. So now we have our 2 points, and we can put it in our equation in order to find the slope. Okay, so I took the points that we got off the line, and I wrote them down in this format. P1 equals 3, 4, and P2 equals 1, 6. Now, we're going to place the numbers in the equation y2 minus y1 over x2 minus x1. So from that we get y2, which is 6, minus y1, which is 4, divided by x2, which is 1, and x1 is 3. So from this we get 6 minus 4 equals 2, and 1 minus 3 is negative 2, which makes the slope of that line negative 1. So here's an example of a line L with a positive slope and a line M with a negative slope. Now, L is a positive slope because as the x values increase, so do the y values. You can tell this by just looking at it. It goes from 0, the x values go from 0 up to about 3, while the y values go from 0 up to about 2.5. But in M's case, line M's case, as the x values get larger from 0 to 4, the y values are in fact getting smaller, going from 5 down to 3. That's the relationship between the positive and negative slopes of a line. Okay, so now we have the line N, which looks a little different than our other lines before, which all had either an incline or a decline or just some kind of slant. So in this case, N is just a horizontal line. So like we do before, we're going to take the points and plug them in our equation. So here's our x1, y1, x2, y2. So with that, we have 3 minus 3 divided by 4 minus 2, which gives us 0 over 2, which is 0. So the slope of horizontal lines are 0, meaning it has no slope. It has no incline or decline or tilt. Okay, so now let's look at a different line, title X, and as you can see it is a vertical line. Now let's try and take the slope of this line, just putting the x1, y1, x2, y2s under the coordinates, and by taking the slope we have y2, which is 4, minus y1, which is 2, divided by x2, which is 2, minus x1, which is 2, which gives us 2 over 0. Now most students would see 2 over 0 and just say, oh, it's equals 0. But in fact it is not. 2 over 0 does not exist in mathematics. You cannot have a zero in the denominator of a fraction. So a vertical line actually has an undefined slope, or the slope does not exist. As a result of the video on slopes, you should be able to compare the slopes of different lines in order to tell which slope is greater or least. You should be able to calculate the value of the slope for a line, and you should be able to identify whether a slope is negative, positive, zero, or undefined.